Hello everybody, I'm Sofia Yfantidou and today I'm going to present to you a webinar on wearable analytics and personalized machine learning. Who am I, you might ask? Between 2012 and 2017, I completed a Bachelor in Informatics from the Aristotle University of Thessaloniki in Greece, as well as I completed an Erasmus semester in the Netherlands. Between 2017 and 2019, I completed an Erasmus Mundus joint master degree in Big Data Management and Analytics from 3 different European universities, ULB in Brussels, UPC in Barcelona, and TUB in Berlin, with a European Commission scholarship. Currently, I'm a PhD student in the Aristotle University of Thessaloniki and a RAIS Consortium early stage researcher in behavioral patterns for sustained user engagement, holding a Marie Curie Horizon 2020 scholarship. My research lab, Data Lab, has 4 different dimensions or key working areas: social network analysis, blockchain technologies, affective computing, and finally, where I belong, sensing data exploration and wearable analytics. So, what am I doing at Data Lab? At Data Lab, I'm working with data collected from smart devices and wearable devices such as smartwatches and connected fitness trackers in order to understand and improve the user experience with these devices. We try to make the user experience not only better, but actually smarter. What are wearable analytics, you might ask? Wearable analytics is a wide domain of research which includes different subdomains, the most prominent of which is human activity recognition and sleep patterns recognition, followed by emotion and stress recognition, physical activity and vital signs prediction, risk and disease detection and management, just-in-time notification, user segmentation, user experience analytics and personalization, data fusion, and correlation exploration. My research focuses around 3 subdomains, specifically the physical activity prediction, the user experience analytics and personalization, and of course, the data fusion and correlation exploration. But why am I so interested in this domain? According to the World Health Organization, regular physical activity helps prevent and treat non-communicable diseases such as diabetes, heart disease, and even some types of cancer, and can generate additional returns on investment for society. However, 1 in 4 adults, and even worse, 3 in 4 adolescents do not follow the World Health Organization recommendations for physical activity. Technology has been shown as a solution to many problems, physical inactivity included. In technological intervention, companies such as Fitbit claim that with their family of fitness products, they can help users stay motivated and improve their health by tracking their activity, exercise, food, weight, and sleep. However, to achieve this promise, wearables such as Fitbit need to achieve successful health behaviors change and to also maintain the user interest or user engagement over time in order to assist and accompany the user in their health behavior change journey. However, prior literature shows multiple limitations of current technological solutions in personal informatics. Specifically, they show dubious effectiveness of technological interventions that try to encourage people to exercise more, ranging from non-significant to significant results in different meta-analyses. For example, there is unclear feature effectiveness. We don't know which technological features work best compared to other features and which features work better for different samples of the population. There is a lack of theoretical foundations in the technological solution, as well as a focus on short-term effectiveness due to the limitations and the difficulty of conducting large-scale studies. Finally, there is a lack of evaluation standards in order to compare and get insights from different intervention results. Additionally, different literature reviews and meta-analysis report various attrition rates ranging from 30% to more than 70% in some interventions. So the question is, how can we achieve this promise of successful health behavior change and sustained user engagement? To answer this question and stay up to date with the state of the art, we conducted a literature review. Based on the 117 studies included in our literature review in the field of health behavior change and user engagement, with a focus on physical activity increase, we will answer the following questions in the next slides. Firstly, how many research studies exist in the field of sustained user engagement and health behavior change in self-tracking technology? Secondly, which experimental setups have been used for health behavior change and user engagement experiments? Thirdly, which are the theoretical frameworks that have been used to increase physical activity and sustain user engagement? Fourthly, which are the most effective design strategies for self-tracking to achieve health behavior change and sustain user engagement? And finally, how can we measure physical activity and evaluate user engagement in self-tracking? To answer research question 1, we should check the following graph. What we can see here is that the self-tracking technology research domain for health behavior change is still in its infancy. However, there is growing interest over the years. At the same time, during our literature review, we've noticed the high interdisciplinarity of the domain, which is evident by its main publishing venues. Specifically, we've noticed that the majority of our articles that are published in journals come from the medical and the medical informatics domain, whereas the majority of the articles that are published in conferences come from the computer science domain. To answer research question 2 regarding the experimental setups, we've concluded that most interventions utilize small sample sizes and short durations, causing potentially generalizability issues for the intervention outcomes and asking for large-scale interventions. This is not surprising given the high financial and time cost of conducting large-scale experiments. Additionally, we noticed that research currently focuses on adults and especially the subgroups of adults such as students or office workers, but self-tracking technology for the most affected society groups by physical inactivity, such as the elderly or adolescents, demonstrates a hidden potential for the future. Regarding research question 3, we've concluded that there is no common framework for self-tracking interventions, not surprisingly given the interdisciplinarity of the domain. However, almost half of the investigated articles either were not based on any theoretical framework or they did not clearly identify one in their full text. Nevertheless, the most used theoretical frameworks are the social cognitive theory, the behavior change technique taxonomy, the trans-theoretical model, the self-determination theory, the goal-setting theory, and the folk behavior model. To answer research questions 4 and 5, we moved from a literature review to the past self framework. What is past self, you may ask? Past self is an evidence-based framework for the design and evaluation of self-tracking technology for health behavior change and user engagement with a focus on physical activity. The past self framework consists of 2 components: the past component, or in other words, the periodic table of self-tracking design, and the self component, or in other words, the self-tracking evaluation framework. The past component is an evidence-based tool to showcase the efficacy of different persuasive design components for health behavior change in self-tracking. The self component is a standardized framework to evaluate self-tracking technology for sustained user engagement. So, to answer research question 4, we introduced the past component. The past component estimates the effectiveness of persuasive system design techniques based on prior literature. In the periodic table that you see in the screen, you notice that each tile represents a different persuasive system design technique, such as personalization, rewards, or goal setting. The color of the tile indicates the persuasive power that the tile and the technique holds. For example, self-monitoring has a dark blue color and hence has more persuasive power than, let's say, rehearsal, which has a light pink color and a score of +1. To experiment more with this periodic table and the past component, you can always visit our live demo, the link of which you can find underneath the video. When it comes to the evaluation of self-tracking technology, we built the self component, which collects and categorizes all reported metrics from prior literature, creating an evaluation standardization framework. User engagement. We categorized user engagement as having 4 different aspects of metrics that a researcher or a practitioner in self-tracking can capture. The perceived self aspect of user engagement includes self-reported data from users regarding a user's personality and psychological state or a user's schedule. The physical self aspect of user engagement includes the body's reaction to the system's influence, such as how much physical activity a user performs in response to the interaction with the system. The behavioral self aspect of user engagement includes analytics to quantify a user's behavior with regards to the system, such as response times or attrition rates. And finally, the environmental aspect of user engagement includes external factors that can affect the interaction of the user with the system, such as the weather, which might affect the physical activity of the user, or the user's schedule. Here we see an example use case of how a researcher or a practitioner can incorporate the past self framework in their product. Here is Alice. Let's see a typical day in Alice's life, which starts at 8 o'clock when Alice arrives at work. The system identifies that Alice arrives at work and sends Alice a reminder to take the stairs. Later on, at 11 o'clock, the system identifies prolonged sedentariness. Essentially, Alice is sitting too long working. Hence, the system sends a suggestion as a notification to Alice to take a walk. In 10 minutes, Alice accepts the suggestion and takes a 10-minute walking bout. Later on, the system predicts that the weather is going to be sunny at the time that Alice leaves for work. However, Alice leaves at work before the system can send her a personalized walking route to home. Hence, Alice just takes the bus home. Essentially, she rejects the system's suggestion. Finally, during the night, the system sends Alice a feedback form to identify her satisfaction levels with a notification timing. 5 minutes later, Alice responds with a response time of 5 minutes. This is just a simple example of how past self can be incorporated in a self-tracking system, capturing the daily life of the user. Future work directions in the domain include interventions targeted to different subdomains such as disease control, smoking cessation, or stress management, utilization of machine learning and deep learning for personalization, analytics taking advantage of newly introduced sensors and functionality such as the ECG sensor and the SpO2, and finally, user segmentation for targeted intervention and analytics. Next, having been up to date with the state of the art, we tried to understand human behavior through data. To achieve this, we wanted to focus on personalization and the effect personalization has on user behavior. This image answers the question of how different are we in reality. I do not want to go into details about the image. What I want you to notice is that in this two-dimensional space, each person, each user, is represented by a different color. We see that child with ID 1 is represented by green color, while child with ID 23 is represented by black color. At the same time, we see that these representations are very different from each other, which indicates that each individual is very, very different from each other. However, the problem with personalization so far is that it focuses on the one-size-fits-all approach. Namely, we get data from the general population, we train a generic machine learning or deep learning model, and we predict for a new user. These generic models are tuned to the average target population. However, good performance that does not necessarily translate to each individual in the population. This might be acceptable in certain domains, such as marketing, but what about health and well-being? Are we actually satisfied by good performance for the average population, or would we like something more personalized? The answer comes from MIT Media Lab, which introduced a new paradigm shift in machine learning called personalized machine learning. In personalized machine learning, we get data from a single user, we train a machine learning or a deep learning model to be personalized to the specific user and then predict for the same user. Notice here that there is a potential to facilitate this training process utilizing data by the general population, essentially to solve the cold start problem and help with the generalizability of the model. The field of personalized ML is quite new, and hence there are multiple future work directions one could follow. Specifically, personalized ML and algorithmic bias exploration, privacy-preserving personalized ML, interpretability of personalized ML models, as well as new subdomains within the health and well-being domain. Similarly, one could pursue different architecture-related or implementation-related problems. Finally, to collect data for further investigation, as well as advance open science, here at RAIS Consortium and Aristotle University of Thessaloniki, we've conducted the RAIS Consortium experiment. The RAIS Consortium experiment includes 41 users from 4 countries which continuously monitor themselves using wearable devices in order to provide physical activity and behavior data, as well as daily ecological momentary assessment surveys and questionnaires. The version 1 of the experiment was conducted between June and July 2021, and the version 2 is expected to start in November 2021. The conclusion of this presentation and the key takeaways is that the domain of wearable analytics for health behavior change and user engagement is still a research area in its infancy. However, there is a growing interest and promising future directions. Most conducted studies, as we've seen, have a limited sample size and duration, undermining potentially the generalizability of the results and highlighting a need for large-scale studies. At the same time, there is a lack of targeted interventions for sample populations with different characteristics in terms of gender, age, sex, ethnicity, or religion. Also, there is a lack of standardization in the design and evaluation, which makes it difficult to compare results and evaluate its work's contribution and update insights. However, here is where the past self framework comes in, with the past component for the design of effective health behavior change technology and the self component for the evaluation of such technological interventions. Finally, we briefly seen the basic concepts and the future directions of personalized ML, which is a new field worth exploring in the domain of health and well-being. Thank you for your attention, and I hope you enjoyed this webinar.